Let me also share my screen. So, as I said before, recently, the Shapley value has been used in machine learning to understand how machine learning models are reaching a decision. So there's now Python libraries for the Shapley value, and there's a lot of interest from a research point of view. If you search Shapley value and explainability, you'll get a lot of entries. Now, the underlying mathematics that have to do with the Shapley value is game theory, and in game theory, specifically, game theory is divided into two branches: the cooperative part of game theory, and what I want to do today is talk. So what is special about the Shapley value? And one of the reasons it is used is that it gives one vector of values that tells you, how much certain, say, pixels in picture are contributing to a decision that I'm seeing a car in the picture. So so basically, the Shapley value is just a single vector, and in that sense, it's an unusual solution game theory. Specifically, usually the typical solutions of game theory, like bargaining set, core, stable set, and so on, kernel, they are a compact set of points. So they don't determine an exact one answer, but they have a lot of recommendation. And maybe that's one of the reasons that the Shapley value is picked up as the tool of choice. Now, there's another tool in game theory that is called the nucleus, and is used as a solution concept in game theory, in cooperative games, and also has 1 point. So what I want to do today is go over the nucleus through an example, and get the flavor of what that solution concept is. Potentially, it may be useful as well for machine learning and readability in machine learning. I'm going to introduce the concept as I introduced the general setting in a specific example. And what I would like you to do is listen carefully to the example, because I'm going to ask your opinion of how do you think what is the right results of this simple example at the end of the day. I'm interested in your opinion. Okay, so we have a cooperative game. If you haven't ran into cooperative game, then don't worry, I'm going to explain it now. So you have 3 players, And you have something that is called the characteristic function. The characteristic function means that a subset of these three players can ensure that they're going to get something, some value or some utility, and they're going to get it regardless of what the others are doing. So what we're saying here is that the single player, 1, 2, and 3, by themselves can't get anything. So they get a 0. Now, player number 1 and number 2, 1 and number 3 can get 1,000, and player number 2 and 3 can get 500. So this is the game. So the story behind this game, maybe it's easier to remember that way, is that think about player number 1 as one type of a person, and player number 2 and 3 another type. Like for instance, you could think of number 1 being a woman and 2 and 3 being a male, and or vice versa, doesn't matter. But the point is that from an so you go, these players are competing for an advertisement, a contract with another company, and if 1 or 2 or 1 or 3 will get the contract, they'll get 1,000, but 2 and 3, which are of the same type, will get only 500. So if you have different types in the coalition, they'll get more. That's the idea of the game. Okay. And there's one other thing that you need to decide is how much the coalition of 1, 2, and 3 can get. So usually they define that as 1,000 under the thinking that if 1, 2, and 3 can sign an agreement between themselves, they could say, okay, we are cooperating. 1 and 2 will go to the adverse to the other company, sign a deal and get 1,000, and then we will split it between ourselves. So usually it's customary to define 1, 2, and 3, the value of that coalition is 1,000 as well. Because, in other words, it's because they could say to 1 to do nothing, and 2 and 3 will do something. They could say to 1 and 2 to do something, and 3 will do nothing, and so on. So that's why the coalition 1, 2, and 3 can make more than coalition 1, 3, and 1, 2, which is 1,000. So we'll set it to 1,000. It can't be more than that. Okay, so that's the definition of the game. Any questions up to now? Okay. So let me ask you a question here. So given that this is the situation, what do you think about a case where the first player is going to get, as an end result, going to get 1,000, and the other two will get 0. Do you think that's a reasonable result? How can that happen that player number 1 gets 1,000? So player number 1
no, player number 1 can't get 1,000 because he needs to cooperate with someone. It's probably not fair that he's the only one getting the entire 1,000.
Yeah, he can't get 1,000 by. So player number 1 can't get 1,000 by itself. So it goes to player number 2 and say, let's go to the let's go to that company and we'll sign together. We'll sign a deal with them, and I want to get 900 and we'll get 1,000, right? Because we signed a deal with the contract with them for the advertisement. Now I want to get, number 1 says, I want to get 950 and you'll get 50. So everything I described here is possible in this situation. Do you think it's reasonable? An end result that most of the money will go to player number 1.
Yes, he probably will get most of the money because if you want to earn the top dollars, the 1,000, you must join him in the coalition. 2 and 3 can cooperate, but they'll receive half as much. So I'm guessing he will get the majority of money.
If 2 and 3 will go together, they'll get 500. So each one of them can get 250, which is much better than the 50.
Oh, 50, yes. I just thought the one will get more than the other one, but probably more than the other one will probably get at least 250.
So you think if one goes to 2 and say, let's go together, I'll give you 250 and I'll get 750. That's a reasonable result.
Yes, it is. That sounds reasonable.
Okay, so now you are ready to understand what the nucleus is. Please put on mute if you're not speaking. Okay, so the other thing that you have in game theory is something that is called coalition structure. So coalition structure is like a partition on the players that happen. Like the coalition structure we just talked about is 1 going with 2, and 3 is left by itself. Another coalition structure is 2 and 3 going together, and another one is 1 and 3. Okay. Now, when you have a coalition structure of 1 and 3 going together and 2 left by itself, or 1 or 2 going together, you may say, okay, maybe 750 and 250 are a reasonable solution. Okay. It's a solution that is possible because 1 and 3 went together. They did a coalition. They earned $1,000 or 1,000 shekel, doesn't matter, and they are splitting it between themselves. And 3 is by itself. So we said 3 can't do anything by themselves. So that's a feasible. This is a feasible payment for this coalition structure, and it's also maybe it's even reasonable. as Guy was saying. But maybe if 1, 2, and 3 forms a coalition, maybe 500, 250, and 250 is a reasonable payment. And maybe if 1 and 2 and 3 goes together, maybe 250, 250, and 0 is a reasonable payment. Like from the perspective of player number 2, doesn't see an advantage to forming a coalition with 3 or with 1. In both cases, if these are the payments, then it doesn't matter. I'll get 215 in both cases. Player 3 and will get 215 in this case. Sorry, in this case, and in this case. So there's no advantage if you believe that these are going to be the way you split. So what is the idea of the nucleus? It's a very neat idea, actually. So given a payment and a coalition structure, so say X is a payment, and we're thinking about the coalition structure that I talked with Guy about. 1 went with 2. Then you can think about the surplus that player can make by breaking the coalition structure. So I'll explain. Like for instance, they call it the access meaning more money. Okay, so 1 and 3 can get 1,000, right? So and now in this payment, 1 and 3 gets together 750, right? So if 1 breaks the current coalition with 2 and goes with 3, there's going to be 250 more shekels to split between them. So that's called that's a positive excess. Okay, so we see here that the excess of 1, 3 giving the payment is 250. Is the concept of an excess clear? Because that's the fundamental concept here. So given a payment, I think about all the other coalitions that are possible. So given a payment and a coalition structure, I think about all the other possible coalitions and see if you can make more money compared to the current payment the coalition members are making. Like for instance, player number 2, if player number 2 breaks the coalition structure, by itself player number 2 can do nothing, so it's a 0. And now he's making 250. So 0 minus 250 is minus 250. So that's the axis. It's a negative axis. Okay, it's clearly not worth for player number 2 to break the coalition and go by itself. But for number 3, it is worth a while to go with 1, and there's an additional 250 that they can split. By the way, 2 and 3 can go together as well, and there's an additional 250 that they can split. Okay? So can you tell me what is the maximum access for this vector? This one? what is the access of this one if collision 1, 2 forms? How much can collision 1, 2 do together? How much? How much can collision 1, 2 do together?
1,000.
1,000. And how much are they making in this payment? 1 and 2?
750.
Right. So what is the access? So if they can make 1,000 and then currently getting 750. So what is the access?
Another 250?
Another 250. Okay. So the maximum, and that's the maximum access. You can check all the different coalition. That's the maximum access. So the idea of the nucleus is to take all the accesses and order them by descending order. So you see I did that here for X. So this 700, 250, and 0. So it's 250, 250, 0, 0, 0, minus 250, minus 750. Okay? So the number of elements in this vector is the number of possible coalitions. And then you order those vectors in lexicographic order. And you take the vector that is the smallest, all possible vectors. And you can prove that that's a single number that is the nucleus. Okay? So the nucleus is the only vector that of access that is meaningful. There's one and only one for any cooperative. Now, going back to my question, what do you think? How do you think the money has to be split here? So do you go with the 750, 250, 0? Or 1, 2, or 1, 3, or what do you think? What is the intuitively correct way of splitting the money here? And what type of coalition do you think will form? Any thoughts about this? So if one goes with 2, they get 1,000, and then, okay, she says, okay, let's split it. I'll get 800, and you'll get 200. So as we talked about it previously, that would not be stable because 2 and 3 can say, wait a minute, we'll go together and each one of us will get 250, which is more. They make that offer. So now the offer on the table is 250 for 2 and 250 for 3 and 0 for 1. And one can break that because it could approach either 2 or 3 and offer slightly more money than 250. But then the one that is left outside can approach approach 2. If 3 is left outside, it can approach 2 and also a little bit more money if it's getting less than 250 and so on. So what do you think is going to be the result of this? No. Do you see where this will land? Any intuition?
שזה באמת הנפילה היחידה, אז שזה לא יהיה בלוק.
Maybe one will get 2/3 of the 1,000 and the other one will get 1/3.
So you mean I think you're saying that it will go 750, 250, and 0. Either one way or the other. Is that what you're saying?
Sounds about right.
Mm-hmm. So think about it some more, because what is not satisfying about this that
No, 666 and 333 for the other one. That's 2/3 and 3.
Just to give a little incentive. Okay.
You're trying to confuse me, but I said 2/3 and 1/3. That's not 550 and 250.
Yeah.
It's 1/4 and 3/4.
Yes. Okay. So as an exercise for everyone, thank you. Try to find if you have an offer that destabilizes guys' idea, and see if you can get a solution that is stable at all. Okay, so I talked about the cooperative games and I talked about the nucleus, and I defined what the nucleus is. It's the lexicographic minimum of the excesses ordered in descending order. And maybe that could also be used for machine learning instead of only Shapley formulas. Think about it and think about what Guy suggested. So thank you very much for joining, and we'll continue next time.
Thanks, Eitan.
Thank you, Eitan.
Bye-bye.